Today we will be seeing about a description of AC wave. Here we will be seeing about magnitude, frequency and phase. Advantages of a pure sinusoidal waveform. Mathematically, it is very easy to write the equation of a pure sinusoidal waveform. Any other waveforms can be resolved into a series of sine or cosine waves, or sum of these waves gives a original waveform. So, when a square wave or a trapezoidal wave is considered, so these waves can be made to become a sinusoidal waveform with the help of a mathematical equation which are represented by a series of cosine waves. The sine and cosine waves are the only waves which pass through linear circuit consisting of passive elements without any distortion. So, when a sine wave or a cosine wave is passed through the passive elements such as resistors, capacitors, and inductors, then the waveform distortion is very minimum or it will not be present. In case of other waveforms, the distortion will be more. The integration and derivation of a sinusoidal function is again a sinusoidal function. This makes the analysis of linear electrical networks with sinusoidal inputs very easy. So, when you integrate or differentiate a sine wave, then its output is again a sinusoidal function. So, this causes linear electrical networks, or to analyze a linear electrical network, this makes the task very easy. Generation of AC voltage. The machine which are used to generate a pure sinusoidal wave is called an alternator. The basic principle of an alternator is electromagnetic induction. The sine wave is generated according to Faraday's law. In the previous class, we have seen how we can generate the sinusoidal waveform with a single loop generator in the principle of electromagnetic induction and Faraday's law. Graphical representation of induced EMF. The instantaneous value of induced EMF in any conductor as it is rotated from theta is equal to 0 degree to theta is equal to 360 degree in one complete revolution is represented as a sine waveform. Here you can see a sinusoidal waveform which starts from theta equal to 0 degree to theta is equal to 360 degree, and this sinusoidal waveform is represented in the figure. The basic terminologies related to alternating quantities are instantaneous value, waveform, cycle, time period, frequency, amplitude, and angular frequency. Let us discuss all these seven terminologies of alternating quantity. First one is the instantaneous value. The value of an alternating quantity at a particular instant is known as its instantaneous value. E1 and E2 are the instantaneous values of an alternating EMF at the instant T1 and T2 respectively, as shown in the figure. Here, the two instants are E1 and E2, which are represented in the sine waveform, and similarly these are the two time periods. At time period T1, the instantaneous value is E1. At time period T2, the instantaneous value is E2. So these are the two instantaneous values at time periods T1 and T2. Waveform. The graph of instantaneous value of alternating quantity plotted against time is called a waveform. So, if you have a lot of instantaneous values from E1 to En, so you will get a number of instantaneous values at each time period. So, if you plot all these time periods in a graph, and the graph x-axis is nothing but the time period, which is theta, and in y-axis it is the magnitude of voltage wave or a current wave. Then while plotting all the instantaneous values from E1 to En, then you will have a wave like this, and this wave represents the sinusoidal waveform. Cycle. A cycle can be defined as the interval of time during which a complete set of non-repeating events or uniform is occurring. When you see this figure, you can see a waveform starts at zero position or zero time and it ends at 2 pi, which is nothing but 360 degree. While seeing this, you can see the wave starts from zero and it having a positive peak and it again returns back to zero and again it is having a negative peak. After that, it again returns back to zero. After this 360-degree position, the waveform will be same as this. Okay, so a cycle means a non-repeating set of quantities. So this from 0 to 360 degree, that is a non-repetitive event, is known as a cycle. Variation occurs in consecutive positive as well as negative loops. When you see here, the two loops, here it is a positive loop and this one is the negative loop. The variation may be there in positive and negative loops, but the time period, if you see here, the after this 360 degree, the same wave will be present here. So it is not such. So this one from 0 to 360 degree is known as a cycle. One such cycle of an alternating quantity is shown in the figure. One cycle corresponds to 2 pi radians or 360 degree, where pi is equivalent to 180 degree. Time period, the time taken by the alternating quantity to complete its one cycle, is known as time period and it is denoted by t seconds. Here, when you see this figure, the time, that is the waveform, starts at 0 and at this point pi is equal to 180 degree. The time is 10 milliseconds, and again at the end when theta is 2 pi, that is 360 degree, time is equal to 20 milliseconds. So when a time period represents in a cycle. So if you draw a cycle and examine the start of the cycle and the end of the cycle, so the duration between the start and end, that is the difference between the end of the cycle and the start of the cycle, is nothing but 20 minus 0, which is 20 milliseconds. So time period is t is equal to 20 milliseconds. At every t seconds, the cycle of an alternating quantity repeats. So, after this 20 millisecond, if you see from 20 to 40 millisecond, the same cycle will be present here. Okay, frequency. Number of cycles completed by an alternating quantity per second is known as its frequency. So, when you define frequency, you need to compare with per second. So, when there is a 1 second of time, then how many cycles are present in 1 second is known as frequency. Here, uh, here is a one cycle which is from 0 to 20 millisecond, whereas if you extend the scale to 1 seconds, then you can count how many cycles are present, then it is known as frequency. It is denoted by F and it is measured in cycles per second, which is known as hertz. So the unit of frequency is hertz. As time period, T is time of one cycle, seconds per cycle, and frequency is cycles per second. We can say frequency is a reciprocal of time period. So we know that T is equal to 1 by F. So if you say T is equal to 20 millisecond and F will be equivalent to 1 by T, which will be equal to 1 by 20 into 10 power minus 3 seconds. So to convert 20 milliseconds to seconds, we are multiplying by 10 power minus 3. So when taking this reciprocal, what you get here is F is equal to 50 hertz. T is equal to 1 by T hertz. In our nation, the standard frequency of operating voltage and current is 50 hertz. At time period increases, frequency decreases. while as time period decreases, frequency get increases. Angular frequency. It is the frequency expressed in electrical radians per second. So, the frequency which is represented in electrical radians, which is represented in electrical form, is nothing but angular frequency, and it is represented in radians per second. One cycle of alternating quantity corresponds to 2 pi, which is nothing but 360 degree. You know that omega will be equivalent to 2 pi f, where omega is the representation of angular frequency, which will be equivalent to 2 into pi is nothing but 180 degree, and f is nothing but frequency. So omega is the representation of angular frequency, where its unit is radians per second. We can also represent omega as omega is equal to 2 pi divided by t. How this t here is, if you say f is equal to 1 by t, then if you substitute f equal to 1 by t, then you get 2 pi divided by t. Thank you.